Now, you might be asking this question, and if you're thinking this, it's a good question. Why is it that we only look at the first terms of these coefficients, and over here we can't do that? We can't just say, I'm going to take 24 and make it go into 1, and then get an 8. That's not going to happen. We have to look at the 195, right? So if that's what you're thinking, that's a really good question, and I'm going to try to answer that for you. I'm going to take this exact same division problem we did right here, and I'm going to do it in the style of the long division of polynomials that we just learned. So what we have here is 10,000, right? So I'm just going to call that 10k. 10,000 plus 9,000 plus 500 plus 60 plus 8. Alright, and we're dividing that by 20 plus 4. Okay, now the first thing we do is see how many times does 20 go into 10,000. 20 is going to go into 100 5 times, and then it's going to go, then 100 goes into 10,000 100 times, so our answer would be 500. Okay, and you realize that this is a far cry from the 800 that we have here. But that's okay. 500 times 20 plus 4 is going to be 500 times 20 plus 500 times 4. Alright, 500 times 20 is going to be 10,000, just like we said. And then 500 times 4 is going to be 2,000, so plus 2,000. Now we're going to subtract. Alright, we're going to subtract these and it's going to cancel. 9k minus 2k is going to be 7,000. Alright, how many times does 20 go into 7,000? Again, 20 goes into 100 5 times. So 100 goes into 7,000 70 times. So 70 times 5 is 350. So we're going to say plus 350. Alright, now 20 times 350 is going to be... Oh, and we should have brought this 500 down. So plus 500. Alright. So 350 times 20 is going to be 7,000. And then 350 times 4 is going to just be 1,400. And now we're going to subtract these again. Now, notice what we're doing here. We're subtracting 1,400 from 500. Because these 7,000s are going to cancel and give us 0. But then we have 500 minus 1,400. That's not something we had here. We're always subtracting a smaller number from a bigger number, like when we subtracted the 4 from the 6, or the 0 from the 8. We're always subtracting a smaller number from a bigger number over here. But over here, everything's fair game. So 500 minus 1,400 is going to give us a negative 900. Now how many times does 20 go into negative 900? 20 goes into negative 900 negative 45 times. Now negative 45 times 20 is going to be negative, and sorry again, I forgot to bring down the 60. Bring down the 60. Negative 45 times 20 is negative 900. Negative 45 times 4 is 180. Negative 180, I should say. And now we're going to subtract again. These are going to cancel. And then here we're changing the signs. So we've got 60 plus 180 is 240. And then we're going to bring down the 8. Hey, I remembered to do it in time. You should be proud of me. Okay, 20 goes into 240 12 times. And then 12 times 20 is 240. 12 times 4 is 2448. And we're subtracting. We get 0, 8 minus 48 is negative 40. And then we're left with 500 plus 350 is 850. Minus 45, so 805. Plus 12, so we get 817. Then, instead of having a remainder of 8, we have a remainder of negative 40. So you're probably wondering what happened there. In the first problem, we got an answer of 815 with a remainder of 8. In the second one, we got 817 with a remainder of negative 40. Do those look the same to you? Well, it turns out they are. Alright, 815 with a remainder of 8 can be rewritten as 815 and 8 over 24. Remember, 24 was our divisor. 817 with a remainder of 40 can be written as 817 and negative 40 over 24. Now let's simplify these and see what we get. Alright, 8 over 24, that's easy, that's 1/3. So our answer should be 815 and 1/3. Now negative 40 over 24 simplifies to negative 5 over 3. Notice we can factor an 8 out of both sides. 8 times 5 is 40, 8 times 3 is 24, right? So we got negative 5 over 3. So we have 817 minus 5 over 3. Well, what is 5 over 3? It's 1 2/3. So 815 minus 1, and then minus 2/3. We subtract 1, we get 816. Then subtract 2/3 from that, what do we get? 815 and 1/3. So our results actually are the same. Now let's look at another way to think about remainders. So remember, our problem was 19,568 divided by 24. And we got two different answers. Our first answer was 815 with a remainder of 8. And our second answer was 817 with a remainder of negative 40. Now we've already seen by turning these into fractions that it actually does work out and that these two are equal. But let's look at remainders another way. Because what's actually the definition of a remainder? Well, if we take the number, let's say 22 divided by 7, 7 goes into 22 3 times. 7 times 3 is 21. And then our remainder is 1, right? And what that means is that if we take 7, multiply it by 3, we're going to get almost 22, but not quite. There's going to be 1 missing. In other words, 7 times 3 plus 1 is going to be 22, right? 7 times 3 plus 1. In general terms, our quotient times our divisor plus our remainder. So we've got our quotient here, we've got our divisor here, and then we add our remainder, is going to give us the dividend. So if you look at that over here, we've got a quotient, we've got a remainder, and the divisor is 24. So 815 times 24 plus 8 should be equal to what we started with. And 817 times 24 minus 40 should also be equal to what we started with. Normally, I hate using calculators, but just to speed things up a little bit, we're going to take 815 times 24 is 19,560. Hope you can see that. If not, you can do it on paper. You should be doing it on paper anyway. Plus 8 is 19,568. Alright, now let's take 817 times 24. 817 times 24 is 19,608. Minus 40. And if you take 19,608 minus 40, what are you going to get? You're going to get 19,568. So, we see that by both understandings of remainders, these two results are equal. Our first one was if we turn this into a fraction. Our second one was if we just take the quotient, multiply it by the divisor, and add the remainder. Either way, we're getting the same result, and it is equal to the dividend. Thanks.